Hello students, welcome to Inside Physics. Today we will discuss about dielectric polarization. What is a dielectric? Dielectrics are nothing but insulators. So what is the difference between an insulator and dielectrics? If an insulator used for a particular purpose like the insulation in a circuit and in a capacitor like a medium. So if it is introduced like a medium in the capacitor, the capacitance may increase so that the dielectric is actually used as the medium other than air or vacuum. So here we discuss some important points of dielectrics and what is actually a dielectric is dielectric polarization, polarizability, susceptibility and dielectric constant and the displacement vector which is introduced to understand the combined effect of polarization and external applied electric field. So here we define a dielectric like an insulator. An insulator doesn't have any free charges, even though it may be a feeble amount of electrons which are considered to be free, and the resistivity of a dielectric is around 10 to the power of 10 to 10 to the power of 20 ohm meter. Resistivity of a material which is in between 10 to the power 10 to 20 to the power of 20 ohm meters is considered to be a dielectric, and these dielectrics are very useful as an insulating materials, and these insulating materials are maybe sometimes liquids also. The synthetic oils and mineral oils sometimes used in the transformers to as an insulator and as a cooling agent also. So here the dielectric material sometimes is used as a dielectric heater. Dielectric heating a useful concept in microwave ovens. So the oven is gets heated up because of the heat generated when an external strong electric field is applied through a dielectric material. So these kind of applications are there in our daily life with dielectrics. So here, and the dielectric heating is also useful for dehydrating food and some elements like tobacco. So when they are preserved, the moisture from the food and materials and some leaves like tobacco which are exported, so the moisture is dehydrated because of dielectric heating. So these are the applications. Now what is happening when a dielectric material is placed in an external electric field, and the external electric field is nothing but the applied field, and the parallel plates are considered to be the two parallel plates of a capacitor. Now we define how the dielectric polarization will happen. Dielectric polarization. Polarization means in general forming into a particular group. That means all the materials or particles or whatever it may be are coming into an orientation because of something which is externally applied. So here to understand the polarization, we will take two metal plates of a capacitor which are of equal length and area of cross section. They are separated by a distance say d, and a dielectric slab is introduced between these two metal plates. Okay, now we know that the capacitor is charged with an external supply of a battery. Then the plates of the capacitors are being charged so that the capacitor, parallel plate capacitor, stores the charge on the plates. So here, if the dielectric slab, this is a dielectric slab. This slab is introduced in place of the air medium, air or vacuum which is there before the dielectric material is introduced between the two metal plates. So here what happens, because of the DC power supply from the battery, the electric field is from positive to negative direction. We always know the electric field will be from positive to negative direction. So here there are some atoms or molecules present in the inside the dielectric material. So the free electrons are not available. All the electrons available inside the material are bound electrons. That means not free. So the bound electrons are always bound to the nucleus. They are revolving around the nucleus and they are bound to the nucleus. So how the external electric field, which is from positive to negative, is affecting the atoms or molecules present inside the dielectric material. If you observe, an atom is present here, say, with the nucleus and the electrons revolving in the orbits. So the center of mass of the electrons which are revolving around the nucleus will be shifted to the positive side of the capacitor, that means positive plate, because the electrons are being attracted towards the positive charge. So there is a displacement of bound electrons with a very small distance towards the positive plate, and the positive nuclei is displaced slightly towards the negative plate. So if you observe, this same atom or molecule will can be drawn with displaced charges like this. The displacement is very small as the atom size itself is very small. So here the negative and positive signs are displaced. So this can be considered as a dipole. What is a dipole? A dipole is nothing but two equal and opposite charges, say positive charge and negative charge, separated by a small distance, say 2a. Okay, this is nothing but a dipole, two equal and opposite charges separated by a small distance. This distance may look large, but if a dipole, an example of a dipole is nothing but a molecule, an atom or an ion which are sometimes polar, which sometimes non-polar. Here the dipole moment of this particular atom, which is transformed into a dipole because of external applied field, will be having a dipole moment. So all the atoms or molecules inside this material will behave in the same way. The negative and positive charges are displaced according to their Coulombic attractive forces. In this way, the dielectric being polarized by the atoms or molecules present inside it, and the polarization is, you can see the polarization inside and outside. So inside, if you observe, so on this side all the positive charge is accumulated, and this side all the negative charge, because see, all the atoms present at this wall being displaced because of the external fluid, and the electrons which are displaced towards the positive plate will make a negative charge on the other side. So if you observe, the positive plate and the side of this dielectric material slab is negatively charged and that side is positively charged. So by this we can say there is an internal electric field developed because of this polarization. So the internal electric field developed will be from this side to this side, the positive side to negative side inside the dielectric. This is represented by E0, that means original electric field, applied electric field. This internal electric field is represented by I, induced electric field inside the dielectric. So if you consider the net electric field in the space, so obviously this electric field will be less than the applied electric field, because this field is considered to be very weak field, because of the polarization only it happened. So now the external electric field, net electric field inside the space between the two parallel plates can be written as E naught minus EI. Okay, so now we can say, because of this electric field inside the dielectric slab, the dielectric polarization is happened because of the external field applied. So that is the meaning of polarization, and the electric field is reduced because of the introduction of the dielectric slab. So electric field is reduced. So what will happen between the plates? Electric potential also reduced. Why? So electric field is related to potential with this relation. We already know from the lesson of electric charges and fields, which is being studied in the class 11 or class 12. So this electric field due to some charge is related to the potential due to that charge with this relation. Here electric field is reduced and potential is also reduced between the two parallel plates of a capacitor. So here potential is also decreased, means here the potential is decreased. So the potential and the capacitance of a capacitor are related as C is equal to Q by V. We already know this formula from the lesson class 12, electric potential and capacitance. C is equal to Q by V. Now the potential is decreased. Because of the decreased potential, capacitance will increase. That is what our aim is. To increase the capacitance of a parallel plate capacitor by introducing a dielectric slab. So this is the application of a dielectric polarization, and the polarization happens instantly without any time lag once the external field is applied. This is a DC power supply connected to these two parallel plates. So now we will see some terms regarding the dielectric polarization. How to define the dielectric polarization represented by P. Now if you consider a small volume in the dielectric, it is a dipole, and it must have a dipole moment. Definitely the dipole moment of a dipole we all know with a relation 2a/q, where 2a is the distance between the two charges and q is any one of the charge. So with this relation we know that each dipole will be having a dipole moment. So the dipole moment in a particular unit volume, small volume, can be taken as d mu, where mu is a dipole moment. So sum of all the individual dipole moments of a particular small volume, if you consider very small volume in this dielectric material, so the sum of all the individual molecules, the dipole moment divided by the volume of the slab, dielectric slab, gives the polarization. That means it is also called electric flux density. So the polarization, the net polarization is defined as the total net dipole moment per unit volume. So this can also be figured with another relation. So here the surface charge density induced on these two sides of the dielectric slab may be considered as sigma p. Surface charge density due to polarization. So here area of the plate, we consider the area of the plate here, and the distance between the plates is nothing but d. So A area of the plate of the parallel plate capacitor, D distance between the two plates, and surface charge density. So this gives the total polarization, that means surface charge density in this space. So this can be written as sigma P into A into D. A area of cross section into space, the distance between the plates, gives volume. So polarization now have become with another relation as sigma p into volume per unit volume gives surface charge density due to polarization. So these are the two relations that can be related to the polarization. Okay. Now we consider what is dielectric polarizability. So polarizability is a particular characteristic of a material, so that how it responds to the external electric field. Something like the the behavior. So what is the capacity to orient all the individual dipoles, that means molecules or atoms, because of the applied field. This polarizability to the polarization is related as the induced dipole moment is always proportional to the external applied field. That already we discussed, and we clearly know that induced dipole moment is directly proportional to the applied field. If you increase the applied field, the induced dipole moment will also increase. The strong orientation happens inside the material. Now we need a proportionality constant to make it into equality. So here the induced dipole moment is equal to alpha into E, where alpha is a proportionality constant which is called dielectric polarizability. This proportionality constant is given a name polarizability of that particular material. So this is how we define polarizability. Now we will move to dielectric susceptibility. Dielectric susceptibility. So susceptible, what is susceptibility? It means the degree of polarization that can be happened in a particular material. That means it is almost like polarizability, but the susceptibility is almost related to that particular characteristic of that material. So the polarization is related to the susceptibility as epsilon naught into E, and the susceptibility, which is denoted by psi, is introduced here. We know polarization is directly proportional to external applied field, and this is susceptibility constant of that material. So this can be defined as the degree of polarization that can be happened when an external field is applied, and the constant is called susceptibility constant. So here we know that epsilon or the relative permittivity and the susceptibility are related as in this way. So here psi plus 1 is related to permittivity, relative permittivity. What is relative permittivity? We all know. A permittivity of a particular medium to permittivity of free space or air. This is relative permittivity. Now, if you consider psi here, epsilon r minus 1. So, place epsilon r minus 1 in place of psi. So, this becomes epsilon r minus 1 into E. So, the terms are all exchanged into permittivity terms. So, this is how we understand the susceptibility of a particular dielectric material. Now, what is dielectric constant? This is an important term. Dielectric constant represented by K. So, dielectric constant K is the ratio of the capacitance with a medium of a parallel plate capacitor and capacitance without a medium. That means the medium may be air or vacuum. This is a ratio. So, this dielectric constant actually sets the material whether it can be used as an application oriented dielectric or not. Usually we require the low dielectric constant materials, and if we want the dielectric heating, we require the high resistance materials of this dielectrics, and this is also can be written as epsilon r epsilon m by epsilon 0 or O. So, permittivity which is equivalent to epsilon r. So, this is the relations that we can understand. By what we can understand a dielectric constant. It is just a ratio, it does not have any units. So, if dielectric constant is more than 1, that means it is having a good dielectric strength. So, here it is more and somewhat it is less, that means it may have the value more than 1. So, the capacitance with dielectric will always obviously increase, so that the dielectric constant will also increase. So, here what is permittivity of free space means 8.854 into 10 to the power of minus 12. So, this is the permittivity. By that we can understand what can be the permittivity of the particular space when another medium is introduced between them. So, here this is the concept of dielectric constant, and there is a last term here in this called the displacement vector. The displacement vector is an auxiliary vector which is purely introduced in this concept to understand the combined effect of external applied field and the polarization. So, the displacement vector, what is displaced? What is actually displaced? Why the displacement term is introduced in the dielectrics? D means the displacement is related to the free charges here, not bound charges, and so that we understand the bound charges are related to dielectric material, the free charges are available only on the parallel plate capacitor. The plates of the parallel plate capacitor will have only free charges, and all the charges inside these plates, inside this dielectric, are bound charges. So, here the displacement means the displacement of free charges, that are electrons, when the EMF of this battery is pushing the free electrons present on this metal plate, and the displacement happens because of the displacement of these free electrons in the plate because of the EMF, which is pushing the electrons away from this uh, plate, negative plate. So this negative charges will accumulate on this plate, and without dielectric we can imagine the accumulated negative charge will be attracting the positive charges onto this plate. So because of this Coulombic attraction, the charges held on this plate, and the capacitor will store the charge while the DC power supply is supplied, and the stored charge is nothing but the displaced charge. So the displacement vector defined as the net displacement of the charge per unit area of cross section across a conductor placed in an external electric field. So this is the definition. How the displacement vector and polarization electric field are related. Now we see that displacement vector is related to external applied field and polarization in this way: epsilon naught E plus P. So epsilon naught is permittivity, E is applied electric field, P is polarization. We have already discussed D is an auxiliary vector introduced to study the combined effect of external applied field and polarization. The polarization will start at the bound charges and end at bound charges. The displacement vector start at free charges and end at free charges. So this is the relation through which we can understand the displacement, electric and polarization vectors. So this is how we will understand the dielectrics. In the next session, we will see some more interesting concepts regarding the dielectric materials. Thank you.